everyone, welcome to our this final practice paper solution discussion video, and this is our second set question, and this is about reading graphs. I have given two different graphs so that when I scroll it you can just look at the graph here. Alright, so let's begin. First question is, what is the range of the red graph? This is the red graph. What is the range here? What is the range here? That is the question. And look at this. Our lowest value is what? This value is given here, already mentioned. This is the lowest value, and the graph is in the positive side. The graph is in the positive side. So this is the lowest where our graph can come. But everywhere else in the up, we have the graph in the upper side. So this is the lowest point, minus 2.833. That is the lowest point. So let me bring some editing tool. So our range, first question is range. So it is y, it has to be y is greater than, range of this question will be y is greater than this value, right? Y is greater than and equal to, because the point actually touched it. Y is greater or equal to minus 2 point, because the point actually touched here, greater or equal to minus 2 point what? Minus 2.833 to 833, greater or equal to minus 2.833. So this is the range. And what is the domain? Next question is let's check. Next question is on the red graph, what is the x coordinate of the x-intercept that has even multiplicity? It is about even multiplicity. Oh, that's a different question, not the range. Okay, if it is range question, then what will be the range? As it is a polynomial function, then the range will be domain will be all real number. Okay, just to give you a heads up. So the domain will be what again? Domain of this function will be all real number. This is not the question. It is not asked here. So domain will be all real number. Range is this. Now next question is, on the red graph, what is the x coordinate? What is the x coordinate of the x-intercept that has even multiplicity? What is the even multiplicity here? What is the even multiplicity here? Let me bring some this. Look at this. Isn't it the even? Because it touched. It touched. So this here the graph touched. This is cross. This is cross. So cross means odd. Only this is even. So what is the value here? 1, right? 1. This is 5. That means 1, 2, 3, 4, 5. So this is 1. That means answer of this question will be 1. Okay. So at 1 it is even multiplicity, because that point is touched. That is the reason. Now we have another graph here. Let me move it up so that we can keep this graph here. Let's look at the question. What is the domain of this graph? This is now here we have something interesting, little bit detailed here. What is the domain here? Look at this. What do you understand? Actually, this graph is somewhat similar to the graph that we discussed somewhere up. This graph is that similar graph. We said that there must be, when the graph is coming closer and closer to this graph is coming closer and closer here, then there must be some asymptote here, and as you can see, there is some asymptote at this minus 2. Remember, actually we solved it in the question number 1, and there must be some horizontal asymptote at plus 1. Now you can see, because now you have the coordinate also, the grid also, the grid also. Now you have the grid also, so now you can see it actually. Now you can say, sir, how do we know that? See, the graph is coming closer and closer to this line. Okay, now that's why you can see. And this value is also like this, because this graph is not crossing this line. The graph is not crossing. There must be some tiger, some elephant, some snake, some cobra, venomous snake, something there on this line, which is our asymptote. So this is the asymptote. So now what will be the domain? As you see, domain is all real number here, except other than this vertical asymptote. We cannot include vertical asymptote, because vertical asymptote is very sensitive. It is very dangerous. Vertical asymptote. Graph never can cross that vertical asymptote. Never. Sometimes graph can cross horizontal asymptote, as you can see. Actually, our graph crossed the horizontal asymptote, which is okay. But graph never can cross the vertical asymptote. So you see, in the left side, graph is going forever, and in the right side also, graph is going forever. So that means all real number other than x is not equal to minus 2. So you will say here answer form is x is not equal to minus 2, all real number, or you can write it in our regular format also. X is all real number, only x is not equal to minus 2, and this is the answer in the set notation. But just only if you write this portion in the answer set, as you can see, correct answer we mentioned here like this. As if you just mention this thing, this is also enough, because we will, this implies that all real number, only this is not included. So that's the answer. What is the next question? What is the equation of the horizontal asymptote? Oh, now you know it very clearly, because equation of the horizontal asymptote is y equal to 1, as I have drawn here. Y equal to 1 is the y equal to 1. See this line, this line, this line, this line. Y equal to 1 is the horizontal asymptote. So y equal to 1 is the horizontal asymptote. Then go to the next question. You can see this side also. Okay, this side also horizontal asymptote is same. We have new graph, and all the graphs is actually coming from the same sources. So I think now you have noticed there is some relationship between the questions also. The reason for this kind of setup is so that you do not have to do the same calculation again and again. This is the reason. Now, okay, this one. See, what is the domain of the green graph? This is the green graph. This is we have to find out the domain. And I think now you know that this is actually some exponential function, and you know in exponential function by default the domain is all real number, because the graph this graph, although the graph is going up, it looks like maybe it is getting straight, but as you can see, the graph is actually moving from point to point. If you look this point, then it moved to the left, so it is going to the left side forever, it is going to the right side forever. That's why domain is all real number here. What is the range of this green graph? This is the green graph. What is the range here? This is tricky now. And you will see that there is some the graph is not crossing this line, this line. Let me draw it here for you. There is a line here. This is the lowest line. It looks like the graph actually touched it. In reality, if you zoom it, in fact, you cannot zoom, I know, this one, but if you zoom it, in fact, the graph never touched it. The graph will not, exponential function, as you know, they never touch it. Okay, normally if I draw any exponential function, you will see that there is some separation here. Suppose if I draw from this direction or even from this direction, normally suppose a graph comes closer and closer. In real graph, there will be always some separation, always some small separation here, and this is there also. Here also we have to consider there is some separation because of the exponential function concept, so there is some separation, and the graph is not coming down to this line, which means the graph is somewhat upper than this line. So range will be all numbers which is more than this plus 2. That means y has to be greater than plus 2. This is the range. Okay, this is the range. Y has to be greater than plus 2. Now next question we can go. So let me clear it up. Next question is this orange graph, and this side also. Let's move it up. Orange graph is here, so that you can see. We can go now down. What is the domain of this graph? So domain is this. See, now what is going on? In the left side, we have the graph in the which side? In the left side. In the right side, nothing. So also you will notice that see the same thing. It looks like here. it looks like the graph is actually just over on this x-axis, but it is not. It will not never touch it, because it will go closer and closer and closer to the x-axis, but it will not cross it unless or until there is some extra number with them. So, and this graph is actually coming from the up, as you know. So we have that idea. So what is going on here? What is the valid x value? Domain is always valid x value. Valid x value is what? It is actually all the real number which is less than 0. So that means x is less than 0. X is less than 0. This side is what? This side is less than 0. Why less than 0? See, all negative number this side. Negative, 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 all negative numbers this side. That's why domain is x is less than 0. And can we give equal? We cannot give equal, because the graph will never touch the x-axis by default, because of this is how exponential function, logarithmic function, this is actually logarithmic function, this is how the logarithmic function works. As you know, logarithmic function is the inverse of exponential function, so their concept is similar. And you will see then in the next question, you will see actually we will have something interesting, that is this question is, what is the range? So what is the range here? What is the range here? Range is what? Range is, now you see there is no forbidden thing. That means range is all real number. So this is the domain, and range is all real number. Range is all real number. Range is all real number. All real number. All real number. You can give this all only, then this will be fine. So this is the domain, and this is the range for this graph. This is the domain, and this is the range for this graph. And now actually you can actually think it now this way if you want to understand it deeply. Basically, do you remember actually in the exponential function, domain was all real number. So, and for the same reason, in the logarithmic function, range is all real number. This is, do you understand? There is some relationship. In the exponential function, domain was all real number. In the logarithmic function, range is all real number. The reason is they are inverse of each other. That's why their x value and y value flips. Okay, changes, shifts, they interchanges. This is the reason. There is some relationship between them. I think this is the last question from this set 2. Yeah, this is 4B. So this is the last question. I'll make next more videos for question number 3 and 4, another 2 videos, so that all of them are you can actually look at this specifically. All right, thank you all. Thank you very much. Bye bye.